box with two wires. Part 1, free body diagram. The first two forces are simply the wires pulling the block upward and diagonally. And then the third force is, of course, gravity. So that would be mg, downward, and then the, let's see, T1 and T2. And then, in terms of T1, what are the x and y components? And so that's just sine and cosine. The angle he gives you is 40 up here, but turns out that's 40 right here also. So the 4t from that horizontal is measured from a horizontal. Therefore, we can pretend it's measured from this horizontal. So 40 from that horizontal. I know this is a terrible drawing, but anyway, from this, you can see the mouse, this horizontal measurement is 40. And then this angle is also measured from a horizontal. There's the horizontal, and it's measured from there, so we can pretend that's down here. Doesn't really matter whether the angle is up there or down here. You end up with the x part of T1 is T1, well, both of them are going to be sine or cosine. Let's see, this is, the x part is the adjacent, so cosine. T1 cosine of the angle, 40 degrees. And then the y will be sine of 40. And then the T2 will be quite similar. T2, x, and y will be T2, and then the angle is what? 55. So there's part 2, part 3. Write out the equations for equilibrium for both the, okay. So equilibrium. In the x direction, in the x direction we have the x and the y. Well, before I write plus, let's see, which one is to the left? Okay, so T1, it's got a leftward x going on because it's from here to the left. And T2 is from here to the right. So let's make that negative. To the left, to the right. This is, by the way, F net equals MA. So there's all the forces in the x direction. I'm going to break it into x direction and then y direction. Oh, by the way, the MA. X direction forces equals 0 because it's not accelerating, it's not moving. Y forces. That's up, okay. T1y plus T2y, both upward, equals 0. Oh, wait, what about gravity? Gravity points down, so let's put a negative on that. Part 4. Write the equations for equilibrium for both. Oh, that's what I just did. And then math happens. So we know mg. Do we know m? Does it give us m? Yes, 50 kilograms. So we know mg. we plug all this stuff in and a bunch of algebra happens. I'm going to do the first step of that. And so this is the x equation and the y equation with the components plugged in. So t1x plugged in there, etc. We want to get it down to just one equation, so I would say let's take the x equation just because it looks a little easier, and let's algebra added that to the other side. Let's put the numbers together because cosine of 55 is a number. So t2 equals t1 times a number. You can type this in your calculator and find out what that number is. And then I would plug this into t2 in the y equation. So copy the y equation, but for t2, put that. And then again, plug all these cosines and sines in your calculator so that you get a nicer number. And then you can algebra for t1. It's really not too bad from there. So then find t1 and then find t2 with that other equation. Done.